back after a few months, I suppose. But what we are going to discuss today is about polymer chemistry. So we are going to discuss about polymer chemistry, polymers. So what are polymers? Basically, polymers are the compounds with molecular weight generally greater than 10,000. Okay, this is a very general statement. The molecular weight greater than 10,000, those compounds are generally termed as polymers. Now, there are few polymers with less than molecular weight less than 10,000 also, those are called oligomers. So what are oligomers? Oligomers are polymers with less molecular weight, that is less number of monomers. What are monomers? That I will be discussing in few minutes. But before that, let us just discuss what are the classification of the polymers, right? How many polymers are possible? Generally, in respect of their origin, okay, in respect of the origin, that is the source. In respect of origin, it can be classified as natural and synthetic. And from the term itself, you can understand that the source, when the source is nature, that is it is found in nature, then the polymers are termed as natural polymers. And when it is synthetically prepared, when it is synthesized in laboratory or in industries, then these polymers are called as synthetic polymers. Now, in natural polymers, we have examples like natural rubber. Okay, natural rubber. This is a natural polymer. Okay, and the cellulose is another natural polymer. Those are naturally available, and that's why they are called natural polymers. Now, synthetic polymers. In synthetic polymers, we have nylon 6,6, right? Nylon 6,6. Okay. We have polyurethanes. We have bakelite. Those are synthetic polymers. Okay. So this was all about the classification according to their origin. Okay, very nice. So now we need to know what are the other aspects of polymers before going into other classification. Okay, before going to other classification, we need to know other aspects of polymers, right? We need to find out what is monomer. We need to find out what is monomer. Now, to understand the concept of monomer, we need to know the structure of the polymers. Okay, polymer means one compound. Suppose A is one compound and it is attached to another molecule of A. Okay, and another molecule of A, n number of molecules of A are attached together to form a polymer. Okay, so Na, as a polymerization reaction goes on, and it forms AN. So this AN becomes a polymer if this N value is greater than 10. Okay, this is another definition of polymer. Okay, but N value is maybe greater than 2 but less than 10, then these are called oligomers. This is another classification of oligomer. Now this A is termed as monomer. Now this A is termed as monomer. Okay, A is termed as monomer. Now this compound, as we have taken only single monomer, this polymer is called as homopolymer. Homopolymer, because only one monomer we have taken to form this polymer. Okay, and N value is this N, this how many monomers are reacted together to form a single chain of a polymer, is termed as the degree of polymerization. Degree of polymerization, right? Or DP. This is termed as degree of polymerization. So we have new classification of polymers, that is based on the monomers used, right? Homopolymer. Now suppose not single monomer but two different monomers are used to form a polymer, right? Suppose this type of reaction is going on, A plus B, and it is forming AB N. Now this we have taken equivalent amount of N, A and B. Then this type of polymers can have different type of classifications. That is, it may be like this: A, B, A, B. This may be like this, right? This may be like this. So this can termed as a copolymer. This can termed as a copolymer. Okay. Now this can also happen, right? So this is also a type of copolymer which is termed as the block copolymer, right? Why? Because you can see a blocks of polymers. This is one block, this is another block. Suppose the blocks are just attached with one another. This is again a B. This will be B, suppose B, B, B. So these are termed as block copolymers, and this is a simple copolymer. Another copolymerization is this can be termed as this is as you can see, the A is coming at alternate positions, also B are coming at alternate positions. So this can be termed as alternate copolymer. Okay. And if suppose this kind of polymer is generated with this type of reactions, A, B, A, B, 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 A, this can also be possible. So now the arrangement is random, right? So now as the arrangement is random, this can be termed as random copolymer. So this is a very simple classification, that is when only one polymer is being used, one monomer is used, then it is called as homopolymer. But when more than one monomer is used, it is termed as copolymer. And in copolymer we have classifications, right, like random copolymer, alternate copolymer and block copolymer. Okay. There is also some branching also, maybe branching can also be possible, that branched copolymer, that is another classification where we have like this A, B, suppose A, B and going on, but with B another A or B is also going down. There's also maybe another A, B is going as a branch. So this can be termed as branched copolymer. Okay. So branched copolymer. So these are classifications of copolymers, but there is only one type of homopolymer. Homopolymer is also branched homopolymer can also be possible, right? Fine. So these were the classifications based on the arrangement of the monomers. So the most important part from this is the degree of polymerization, that is how many monomers are attached in a polymer chain. Suppose a polymer structure is like this: A, B, A, B, A, B, A, B, and it is going on. Then what is the repeating unit in the polymer? The repeating unit is the smallest unit that gets repeated in a polymer chain structure, right? This whole structure of a single polymer molecule is termed as a polymer chain. Okay. So the smallest part that is being repeated in the polymer structure is called as the repeating unit. So what is the smallest structure in this? The smallest structure that is getting repeated is this one, right? So this is called a repeating unit. In case of homopolymer, the degree of polymerization is basically the number of monomers that is being used. But in copolymer, when we are using two monomers, then the degree of polymerization is actually doubled. Actually, double the number of repeating unit. So, how many this AB is there? This is called as the repeating unit number. So, repeating unit is basically N. So, from repeating unit, we can calculate the degree of polymerization as 2 into N, because we have two monomers, right? This degree of polymerization is often termed as Xn. Okay. So the degree of polymerization is doubled, right, in case of copolymers. Fine. Now another part we need to get into is the molecular weight determination of polymers, right? So in polymers, as I have already mentioned, that polymers do not have this specific molecular weight. A single polymer will not have a specific molecular weight. It will form different type of polymer chains, with different molecular weights, and it will form a distribution. What kind of distribution? If we plot this as an axis, right, x-axis, we plot suppose a molecular weight. We are plotting molecular weight suppose in this region, okay, and we are suppose number of polymers that is having the molecular weight, right? So this forms a distribution like this only. This forms a distribution like this. So that means it is a probability of forming the different molecular polymers. Why? Because in a particular reaction, when this reaction, suppose this reaction is going on, A plus B, and this n number of molecules is m moles, okay? If this reaction is going on, and it forms suppose A is there, suppose X, and B is Y. Now the molecularity is increased, so the probability of this molecule interacting with another B or A is getting reduced, right? So the higher molecular weight polymer probability is getting reduced, right? So this is one of the factors that determines the distribution of the polymers, right? Polymer molecular weight. So the probability of reaction goes down with time. So the number of polymers having higher molecular weight is also decreased. In beginning also, in the lower molecular polymers are also in less probability. This probability because of other factors like probability of reaction, orientations of the monomers, and all these factors are important in a polymer reaction as well as in other organic reactions or inorganic reaction, any reaction. Now these are the factors you have already learned in chemical kinetics, right? So this is the fact that the polymer will not have a specific molecular weight. That is, we cannot say a polymer having molecular weight equals 11,238 gram per mole. We cannot say that, right? We cannot say that because it is always a distribution of molecular weight. So now, as this is a distribution, we have to find out the average molecular weight. Right? Now, average molecular weight. Now, how many? There are different methods of calculating average molecular weight, and with respect to that is due to these different methods of average molecular weight calculation, we have different classifications of the molecular weight as well. Okay, and molecular weight of polymers are classified in basically two categories, mainly two categories that are important for your exam purpose also. One is number average molecular weight, and this is termed as Mn cap. This is number average molecular weight. Another is weight average molecular weight, and that is Mw, right? There is another is viscosity average molecular weight, and that is termed as V, right? So what are the formulas, how we can determine, what are the definitions of these average molecular weights? And you can from the name itself you can understand that it is number average. So that means the higher number of molecules that are having the molecular weight highest than the majority of the molecules having the molecular weight. Okay, that is called the number average molecular weight. And weight average molecular weight means the majority of the weight that is in the dispersion is termed the weight average molecular weight, right? And viscosity is as the molecular weight of the polymer increases, the viscosity also increases. So with respect to that, the highest viscosity, the average viscosity of the dispersion is the viscosity average molecular weight. Fine. So there are formulas to determine that. Now to determine Mn, we need to do the summation of n equals 1 to I. I is the number of ith monomer, okay? Ni Mi divided by Ni. This Ni is nothing but number of monomer, and Mi is nothing but the molecular weight of that monomer, okay, ith monomer. If there is 2 monomers, you have to calculate accordingly, right? You have 3, 4, 9, n number of monomers, ith number of monomers, then we have to use this formula. And for MW, we have this formula same, Ni Mi square divided by Ni Mi. This is the formula to determine the weight average molecular weight. And for viscosity average molecular weight, we have the similar kind of formula, but with different power of Mi, Ni Mi square, and that is the viscosity average molecular weight, right? That is the viscosity average molecular weight. So these are few different molecular weights of polymers, the average molecular weights. Now, what is the impact of this, right? What is the utility of this? So you know this, and you also have this dispersion, right? So very clearly you can understand that this point, if this number of polymers, if this number, so this is the nothing but the Mn value, right? And here somewhere here will be the Mw value, right? And this will be the Mz value somewhere here, right? Sorry, Mv. You can turn as we are turn the viscosity average. So this is V, right? So this is the dispersity of the polymer molecular weight. Now fine. Now there is another term that is called the polydispersity index, right, which determines how the dispersity is, right? So this dispersity may be higher, dispersity may be lower. So these two kinds of plots we can draw for a polymer, right? This molecular weight here, and this number, suppose n, suppose. So two kinds of peaks we can obtain. This is one dispersity, and another may be like this. Another may be like this, right? So you can see that these are two different dispersions, right? To different number of extent, this is two different dispersions. So denote how good is the dispersion quality. The less the broadness, the better is the quality of the polymer, because the more specific the molecular weight becomes, right? So this we can determine from polydispersity index. From what? We can determine it from polydispersity index. Polydispersity index. This determines the how broad the dispersion is, right? So this is termed as PDI, polydispersity index. Okay. How the PDI is determined? The PDI is determined as the molecular weight average molecular weight divided by number average molecular weight. This is the formula to calculate PDI. Now, if PDI is greater than 1, this is called polydisperse sample. This is the polydispersity is there, right? If PDI is equals to 1, then this is monodisperse. If PDI is 1, then is the ideal situation, right? When we can if PDI is 1, we will obtain a peak like this, just like this. We will obtain a peak just like this. So this is the ideal situation, a very ideal situation. Okay. getting a PDI 1 is very difficult. It's very difficult because it's ideal situation. In case as well as we all know, the ideal situations are very difficult to get. Okay. Now let us just we have already mentioned that there are different types of molecular weight molecular weight calculations: M, W, M, Z, number average, weight average, and Z average. Okay, so in them the order, if order is asked, this question is often asked. The Mn value is the lowest, and Mb, viscosity average, is greater than Mn. Okay, so this is not right. Then it is greater than MW. MW is greater than Mn value, and Mz value is the highest. So this is often asked, right? This is often asked in questions. So let us find out a simple problem, solution of a simple problem. That is, let us suppose in a question it is asking a molecular weight weight average molecular weight and number average molecular weight of a polymer. Okay. So just let us find out. So in a question, suppose it is given that 10 monomers with molecular weight 10,000 has reacted, 5 monomers with molecular weight 5,000 has reacted to form a polymer. Okay, so let us calculate what is MW and what is Mn. This is asked. MW and Mn is asked, also PDI is asked. So how you can calculate? You can simply use the formulas, right? You will use this Mn. First you calculate Mn. So Mn is equals 5 number of molecules are having so Ni, Mi, then Ni, summation I. So you can calculate the 5 number of molecules are having 5,000 molecular weight divided by 5 plus 10 number of molecules having 10,000 molecular weight divided by 10. That gives us 15,000, right? That gives us 15,000. Now let us calculate MW also. So MW is nothing but Ni, Mi square divided by Ni, Mi, and it is summation. This calculation is quite bit lengthy process. So 5 into 5,000 its square divided by 5 into 5,000 plus 10 into 10,000 its square divided by 10 into 10,000, right? So 5,000 cancels, 10,000 cancels. Also 10 and 5, 10 and 10 and 5 and 5 cancel. So this gives us 15,000 again, right? So from here we can calculate the PDI as 15,000 by 15,000. So this gives us 1. So PDI here is 1. The answer is 1, right? So the answer is 1. This was a very simple question and very simple answer also you got. Very nice. Now okay, so let us find out a problem, a genuine problem. Okay, no, so we will be doing a problem of this related to this molecular weight calculation and all in the next video. Okay, we will be solving, but this is all for today. So we will be in next video what we will be doing, in next video we will be doing the another type of classification, structural classification of polymers and problems related to MW, MN, MZ values, right, and PDI, okay, and few synthetic procedures. That is all for polymers that will be required in CSIR, NET or GATE or JAM or this kind of competitive exams, right? This is all from polymer. This is a very small chapter. This is a very small topic, and you can at least score 4 marks from here in CSIR, and you can get 4 to 8 marks in GATE. Okay, so this is an important but very small topic, right?